Hello again, and welcome to forecasting recording number 3. And in this recording, we will talk about the simple exponential smoothing. Simple exponential smoothing is using when we have no seasonality and no trend. And as you take a look here, this may be fuzzy, but in simple exponential smoothing, or SES, we will be using a smoothing constant called alpha. That smoothing constant needs to be between 0 and 1, and it can be 0 and it can be 1. So let's go to discuss and do an example. When we do simple exponential smoothing, the basic formula, let's make this a little bit bigger, is F is for forecast, uppercase F is for forecast, uppercase A is for actual. The alpha used is the smoothing constant. And this here tells us that the next forecast, T is the period, okay? So Ft plus 1 is the forecast of the next period, or the forecast in period T plus 1. Ft is the forecast for period T. A of T is the actual, is the observed value in period T, and alpha is our smoothing constant. So this formula is the formula used for simple exponential smoothing, and and so we can write it. We can also write it this way, okay, and it will be the same thing. Okay, so T is the period that we're in. Now, if we multiply things here, this is equal to 1 times f of t, this is f of t. Then you have minus alpha times f of t. And then you have plus alpha times a of t. So this can then be, if we group, can be f of t, and then plus, pull out the alpha in these two as a common factor. And inside, we will have the actual at period t minus the forecast value at period t. So this and that are exactly the same thing. There's a little bit of math involved, and the math will become more complicated when we go to double exponential smoothing and when we go to the Holt-Winters additive model, or the Holt-Winters multiplicative model. I will illustrate how this works for a specific value of the alpha. Okay, so let's take this out of the way, clean up all of that, and all right. So we are given the weeks and the actual units sold. All right. And we want to calculate, so this blue will go with this blue. we want to do simple exponential smoothing for the tablet computer sales, and we're doing this using various smoothing constants. Constants, yes. So this is when alpha is 0.10, alpha is 0.20, ta-da-da. This is alpha equals to 0.6. And I'm going to show you how these values under 0.6, under the alpha value of 0.6. So this is smoothing constant alpha. Okay. So when alpha equals to 0.6, I'm going to show you how these values are derived. And this is explained in the book. All right. So here are my values. All right. So what we do, we this is F1. Okay. So F1 equals to A1. Right. So this is F1. And this is A1, the actual in period 1. So A1 is 88, the actual in week 1. And so F1 is the forecast. We set it equal to A1. We do the same thing for the forecast value in period 2. We set that equal to the actual of period 1. This is so that we can get started. Then we're now in week 3. So let's put that in a box so that we know that we are working with. So that we know that we are working with this week. All right. So this is where we are. Make this a little bit thicker. Okay. So this is where we are. And I want to find f of 3. So we have f1, f2. We initialize the forecasts, these first two forecasts. And then I need to find f3. So the formula, right, that we have is right here. So t plus 1 is 3. So this would be f of 2 plus 1 or f of 3. So we write f of 3 in this format, okay? And okay, so let me annotate. So whatever I'm doing is for this row. So f of t plus 1, so t plus 1 is f of 3, all right? So this t has got to be a 2. So this is f of t plus 1 equals 1 minus alpha, right? So that would be, so this is f of 3. This would be 1 minus 0.6, the alpha up here, times f of t, which is f of 2. Because if t plus 1 is 3, then t must be 2. All right. So, all right, let me make some space. Okay. Then plus I'm using this formula, right? Alpha, which is 0.6, times a of t, which is a of 2. And I have this right here, all right? 1 minus alpha times f of 2 plus alpha times a of 2. Well, f of 2 is 88. So here we have 1 minus 0.6 times 88 plus 0.6 times a of 2. A of 2 is 44. Times 44. And this will give us 61.60. So let's go ahead and right here and do it. So we will say equals, all right, parentheses, 1 minus the 0.6, which I gave it a name variable. I called it alpha dot 0.6, times f of 2, and f of 2 is this one right here, all right, plus alpha, all right, times a of 2, times a of 2. Let's do it clear, right? So let's put the parentheses here, right? Press enter, and that's the 61.60, okay? In the same manner, the next one, okay? In the next one, we, so we have, for the next one, we want to do, the next one would be f of, it's f of 4, which is f of 3 plus 1. This is f of 4, and that would be 1 minus alpha times f of 3, right? Plus alpha times a of 3, right? So what is that? This would be 1 minus 0.6. F of 3 is 61.60 plus alpha times a of 3. A of 3 is 60, right here. And that should give us 60.64, right? I'm recreating this column. So let us go and do this right here. And let me clean up. So this is 1 minus alpha, all right? 1 minus alpha. And by the way, when I created the name variable alpha 0.60, so you click there, you call it alpha 0.60, that actually is the same as, so this is N3. So if I go to name variables, formula name variables, I should see alpha 0.6 right here, all right? And if I double click, this tells me that right here, this right here, if you cannot see it, this says alpha 0.60. This is the name of the variable, alpha 0.60. And this tells us that this is equal to $N $3 together with the spreadsheet name, all right? So once you set the names of the spreadsheets down here, if you use them to create name variables, you don't want to change them, because if you change them, some of these name variables, they may automatically change it here as well, but overall, you do not want to change spreadsheet names once you use them all over the place. Okay. And the $and $3 basically helps you when you keep using the formula, and eventually if you want to paste the formula by clicking here and drag it down, all right? So you see that you get the correct values. But so it's good to use name variables whenever you can, all right? So let's go here. I'm trying to recreate this 60.64. So this would be equal 1 minus alpha times the previous forecasted value plus alpha times in the previous period, the actual of the previous period. And that gives us the 60.64. And once you verify that 2 or 3 values of these forecasted values after the initialization, the ones that are initialized, of course, then you can just select these. And once you verify that the formula works, and then you select the last one or the last two, but select the last one, go in the lower right corner, click and see how the crosses stick. When I go over the right lower corner, it becomes a thin cross, and then you go all the way down. And now these values are the same as the values here. And I created those. And then, oops, then what I also want to do, I want to graph the actuals versus the forecast values. and so let me actually delete this, and I will show you for alpha equal to 0.6. So I'm going to select these two columns, the week, the actual. So let's call this actual here. Actual, let's call it actual, okay? And then the 0.6, the forecasted values when alpha is 0.6. So I'm going to select, let me color all the columns that I'm going to select in blue. So I'm going to color these columns, these 3 columns in blue. I'm going to select these 3 columns. Then click Insert, Recommended Charts, and have this graph. And this graph is compares the forecast to the actuals. Okay, the forecast to the actuals. This here is the forecasted values. And the other one is the actuals. So it's a good idea to label the title so you know what it is that you have. So this you can say forecasts using the simple exponential smoothing. You want to have the whole name, simple exponential smoothing with alpha equal to 0.6. And you want to change the legend. So instead of saying series 1, it will say, for blue, it will say so blue is actual and the orange is the forecast. So you want to click here, go to the plus sign and give names to the titles. So this here is the x-axis is weeks, all right? and make this, of course, bigger. All right. The y-axis is units sold. All right. All right, units sold. And so you see for each, let's make this bigger too. All right. And you see for each week, you have the actual and the forecast. Weeks 1 and 2, you have the forecast is the same as the actual of week 1. And so week 1, this is week 1. In week 2, the actual is so remember, F2, F1 is A1. Okay, F2 is A1. So these are the F1 and F2, 88. So this is F1. This is F2. F1 and A1 are the same. Okay. But here is A2 right here, and here is F2. So we have an error. And then the error in week 3 is this difference. The error here is this difference. And then you see that the forecasts sometimes are less than the actual, and other times they are greater. So this difference, you want this difference, you want this area to be as small as possible. Okay. And of course, anytime you do forecasting, it's extremely rare that the forecast and the actual are the same thing. That's almost impossible. Okay, so let's go back to the concepts. And so we went over the simple exponential smoothing, doing an example. And you can, of course, do this with different values of alpha, as we had. And at the bottom, if I click here, at the bottom here, you can calculate these metrics, the mean absolute deviation, the mean square error, the root mean square error, and the MAPI, and then compare and see which one has the smallest RMSE to pick that. You want to compare which has the smallest RMSE, and then you pick the alpha smoothing constant that would be the best one. Of course, I did this whole thing manually in Excel. The idea is to, after you know how it works, after you know the inner workings of simple exponential smoothing, and you understand it very well, then you really want to use software. As the forecasting techniques are getting more sophisticated, the math behind it becomes more complex. and so you really want to use software, but here we have to do the whole thing in in Excel. And so that is why I'm showing you the math. Thank you very much coming to this video. In our next recording, the we will do the double exponential smoothing, and here is where I'm repeating this. One software is the ASP software that we cannot use. um, we could use it, and that may be another video, how to use the ASP software. And it used to be called Excel Miner, and that software is actually does a pretty good job, and it does many other things that are more complicated if you try to do them manually. So the new name of Excel Miner is called Analytic Solver Platform, and so this is one of many software, and this is not even the best software out there, but this software is right here. This software is has a cloud option that you can run things in the cloud, and ASP stands for Analytic Solver Platform. Okay, let's see. So this is the end of recording 3. In our next recording, we will do double exponential smoothing, and we will illustrate that via an example. So I will see you in the next recording.